All right, so what's the rule for adding that we talked about on Friday? Least what? Least numbers behind the decimal. So how many numbers behind the decimal there?
2.
And how many there?
3.
So I only want how many in my answer? So 19 point what? 35 is good. All right, and the second one, we're going to say 0.0256 times 23.60. And I have a syntax error, so clearly Ms. Wall did not punch it in right. There we go. 0.60416. All right, and so when I round off, you can put that at 0 hay as a billboard if you'd like. It doesn't matter because it's not significant either way. So what rule do I use when I multiply? So how many significant digits are here? And how many are here? So I only want how many in my answer. So what are my first 3 significant digits? All right, so the leading 0 again is just a billboard. You can keep it if you want it, or you can drop it, either one. And then 604. Any questions about that? Now, for those of you who came in late, because you were getting your breakfast, we talked about these two being in scientific notation. If we do the quiz today, or we will definitely do it tomorrow, when you do these 2 questions, all right, you're going to calculate in scientific notation. The significant digits work the same way. In this one, you're multiplying, right? So go ahead and calculate your answer in scientific notation. So 1.2 second EE 6 times 6.35 second EE negative 8. And mine's not in scientific notation, so let me put it in scientific notation. And I get 7.62 times 10 to the negative second. Okay? Now, once I get my answer in scientific notation, I'm going to round it to significant digits, right? It's not so bad, third. It's a smaller crowd, but when they got 60 of them in second, it's a lot. All right, so when you look at number 3, how many significant digits do you have in this first number? 2. We don't count this. This is not significant. Okay, we only count that. There's 2. This again is not significant, so how many are here? So how many can I have in my answer? So what am I going to round this answer to? 7.6 times 10 to the negative second. So that will be gone. All right, same thing on the next one. This one we're dividing. So 3.56 second EE 12. Divide 2.136 second EE 5, and we get 1.66 forever. And I'll just write down a few of them. Times 10 to the 7th. All right? So again, the times 10 is not significant. So how many significant digits are here? And how many are here? All right, so I only want how many in my answer? So what am I going to round it to? 1.66 times 10 to the 7th. Or if you wanted to round up, you'd say 1.67 times 10 to the 7th. Say what? I know. There were more on the calculator. I just wrote down a few. Okay. Questions about how to do that? Anybody? On the other? Because you're going to have to do this on the lab. Now, I need to hand back the lab papers from Friday. So those of you who are absent Friday, so that was Destiny, you missed quiz and lab. Pops? I'll make that up. I'll be here Tuesday, Wednesday, and Thursday of this week. And I always recommend sooner rather than later to make up stuff.
Why do I have 199 on that?
Is that quiz grade?
No, that was the lab.
That's a quiz grade.
Oh, I thought it was the lab.
Okay. It clearly says quiz at the top.
I didn't.
Clearly not.
Whoa. Keep moving.
So what next? Yes, you did. There's only 7, and you said there were 8. There are 8 in the number. Now, some of us have some issues on this lab we need to fix before I let y'all in the lab today, or y'all are gonna lose major points when we do this lab.
Oh my God. I told you. I told you she could have this, and they put the. I told you she could take points off you and put the grams on it.
You didn't tell me that.
Some people did not.
I knew she was going to do
Remember that. Yeah, you're lucky I saved you on that one. You would save me.
Celsius, come on.
Look here.
Oh, the degrees?
I didn't know that's it.
I did.
All right. First of all, if you do not have a unit on your answer, I took off -1. I told you I would. I will today. Because some of you will not believe me, and you will still not write your unit on your numbers. Okay? If you write a number on your lab paper, listen to me. I don't care if it's in a data table or if it's in a calculation section. If you write a number down, it has a what on the end. Don't forget it. I won't. And when I'm grading your paper, I'm going to take a point off if you don't put a unit on the end of a number. It has to be there. Okay? Now, the significant digits. Some of us jack those all up. Now, you wrote all the answers right. I don't think I took off points on anybody's conclusion questions. So, if you read a math, how many places behind the decimal did you have to have? 2. So you want to tell me why people have 1 place behind the decimal on math? So, today, when you go to the lab, and you take your blocks of wood back there, and you set your block of wood on the scale, and you read the math, and you're one of those people who only have 1 place behind the decimal, and you're like, I got to. You need to put your hand in the air, and you need to call me to your lab count, and you need to say, Paul, I don't get it. I need to know how to get 2 places behind the decimal. Okay? When you read volume, there was only how many places behind the decimal? 1. Some people had none. Okay? If you read to the 1's place, the guess is where? In the what place? What's after the 1's? The 10th place. Some of y'all just rounded that off. If it was 41 point something, y'all made it 41. Okay? The thermometer was the same way. There should be a decimal there. But a lot of groups didn't have that. Now, most of the mistakes were made with a ruler. You're going to use a ruler today. Okay? The ruler reads to the 10th place. I don't know how many people wrote inches, first of all. If you wrote inches, I didn't even look at your significant digits. Okay? I didn't care if your significant digits were right. I don't know how many people wrote 11.5 by 8 inches. We have not read English units all semester long. And granted, we've only been in here 4 days, so that's not a lot of time. All right? Well, he's not been here but 1 day out of 4. So why would you listen to anything he had to say? Let me be clear. And this is probably hurtful, and I shouldn't say this. He's absent a lot. I wouldn't listen to anything he's got to say. I told y'all to just sort of let him ride along so he can learn something. Don't listen to anything the boy's got to offer. Okay? Because he's clearly not going to know much given he's not here. Now, I told you it was going to sound bad. When you go to the counter over there, the ruler reads in centimeters. It reads to the 10th place. So it's going to have a guess in the 100th place. So how many places behind the decimal should you have on all those ruler readings today? If the ruler reads to the tenths, okay, so let's say that you read 21.7, which is in the 10th place, where's the guess going to be?
100.
So you're going to have how many numbers behind the decimal when you read? 2. So when you're looking at your data table today, and you got a mass, which you just told me had how many places behind the decimal, and you look at your measurements for length, width, and height, it's going to have how many places behind the decimal? 2. If you look at your data table and you go, I only got 1, what should you say? You better do something to fix it or you're going to lose points for significant digits. Okay? It has to have 2 places behind the decimal. All of them have to have units today. When you're reading your lengths, your widths, and your heights, because they're in metrics, all of the units are going to be what? They're going to be centimeters. The masses, only a couple of people forgot to write. Grams. Don't forget that today, okay? Everybody good with that? Now, let's see how you did on your homework before we do this lab. See if we're good, if we need more practice, where we're at. Although half of you already did the extra practice. 1. You should have 18.3. Now, if you left it at 18.2, that's completely cool. All right, number 3, 20.41. Number 5, 548.68. Number 7, 23.0. If you left it at 22.9, that's completely cool. Number 9 should be 375.5. But if you left it at 375.4, that's completely all right. Questions about any of those 5? We feel okay about those? All right. Number 11 should be 15. But if you left it at 14, that's okay. Number 13 should be 1.2. Number 15 should be 0.3. But if you left it at 0.2, that's okay. Number 17 should be 150. Number 19 should be 110. Questions? Any of those? You want me to do? Any of those on the page? Yes, sir.
17.
17. All right, so we have 271,000 times, and I'm just going to put that leading 0 there so we see the decimal, divided by 2.36, and it's squared. Now, everything in number 17 is a multiply or a divide. All right, it's got a squared in it, but it's not going to change anything. Okay, there's no weird add, subtract, multiplies, and a divide all mixed up. So 271,000 times 0.0031, whoops, divided by 2.36 squared. All right, when I do this, let me get rid of scientific notation. I get 150.8366. And I didn't write everything down, okay? So, you don't have to. I just wrote it the way it is on paper. But it didn't matter. You didn't have to put it in parentheses. I didn't put it in parentheses when I punched it in. All right, so when I look at this, I have 3 significant digits. I have 2 significant digits. I have 3 significant digits. And it's all multiply and divide. So I won't have any significant digits in my answer. So my first 2 significant digits are going to come from here. And they're these 2. So I'm keeping the 1 and the 5. But that's in the hundreds place. I want to keep it there. So I'm going to include the 0 so it stays in the hundreds place. So 150. Anybody else? Question on the homework? Anything? Number 19. All right. Number 19 is the one I would have expected y'all to ask. So you have 2.86 divided by 0.013 times 0.938 divided by 1.9. And again, this all has multiply and divide. So nothing odd. So we get 108.610, and I didn't write everything down. I quit there. All right, so when I look at it, all right, again, multiplying and dividing, so significant digits. How many are here? 3. How many here? How many here? And how many here? So I only want how many in my answer. So that's going to give me 108, right? But how many do I have in my answer? I'm going to have 3 there. So I've got to round it, so I only have 2. Well, what can I do? Most people lean towards saying, all right, well, if I do that, I can just keep here and here. But then if I fill in with a 0 like we just did, I wind up with how many? How many do I get there?
1.
I only get 1. So if I do that, I either get 3 or I get 1 significant digit. So neither of those are going to give me what I want. Some people eventually figure out that you could say, well, I could round that to, like I did, and I could change it to 110, which will give me 2 significant digits, which is fine. But one of the things you can do that some people like, a lot of students just don't gravitate to this, and I don't know why, but if you put it in scientific notation, you can always round it to what you want. So the decimal is here, right? 1, 2, so 1.08 times 10 to the second. Now just round it off to where you want it to be. So it would become what? Can you tell me what it would be if we want 2 significant digits? Go ahead, Rebecca, be brave. What would I drop off?
The 8.
Yeah. Now it's in 2 significant digits. And that would always be okay. Okay, I would never tell you that's wrong. Anybody else? Question on the homework. Now, my plan had been to practice the even numbers before we did the lab. Do you feel like you need any practice, or do you feel pretty comfortable with this? Where are we at? You're cool. Okay. All right, so let's say that I sent you to the lab and you have a mass of this block of wood, and the mass of the block of wood weighs 34.25 grams, and the length of the block of wood, all right, is 12.15 centimeters. The width is 7.81 centimeters, and the length is 4.8 centimeters. All right, I want you to calculate the density in the correct significant digits. All right, find me the density in the correct significant digits. Now that means you got to find the volume first in the correct significant digits, and then find the density in the correct significant digits. All right, somebody tell Tevin how to find the volume. What did we do last week? You got to find the volume of the block of wood.
D equals M over.
I completely failed last week. You know,
That's density. D equals density.
I mean, you can still find the volume using that formula, can't you?
How you find
Yeah, but
volume?
we don't have density or volume.
you know. Let me tell you the story from last semester. I was tutoring this child from another school, and I asked my students this question. Or I was tutoring this child, and I asked her this question, and I just knew my kids knew it because I am the bomb. I knew that I had taught this lesson so well, and my students just knew the answer. And when I asked her this question, she just looked at me like, "What are you talking about?" I was like, "Oh, dear God, you're doomed." So I came back to class, and I asked my students this question. And they said, "We know the answer, Miss Wall." I said, "Okay." And so I asked them the question. And they all looked at me, and someone yelled out the right answer. Somebody said, "I know there were 18 groups on the periodic table." And I said, "Oh my God." I said, "I'm going to become an alpaca farmer in Montana because surely I can raise alpacas better than I teach chemistry because I suck at my job." Now, after 4 days together, if y'all can't tell me how to find the volume of a block of wood, I must say I'm really going to invest in alpacas and move to Montana because I really do suck at this job. Now, there's got to be somebody in this room who can tell me how to find the volume of a block of wood. Thank you, Jesus! Because we cannot find the density of a block of wood with density because we don't know the density yet. That is what y'all are finding for me. Okay? So when y'all go to the lab in a little while, y'all are going to have to use this formula to find the volume of a block of wood. Okay. It doesn't, oh, I didn't do height. We'll make the 4.8 height.
All right, I was about to say she better go.
Sorry, we'll make that the height. So if I start looking up real estate prices this semester, y'all will know y'all are doing poorly.
I got
All right. Now, find that the correct significant digits. And then we'll see if we're all on the same page or not. And this is the
What'd you say?
I gotta let it.
Y'all had time, or do I need to be patient? Where are we at? You're good? One more second. All right, I can be patient. All right, have I given enough 1 seconds or? Yeah? All right, so when you were calculating the volume, all right, and we were multiplying, what was the rule for multiplying? Because we multiplied length times width times height. Once we figured out that was the formula, right? So what do we know to do? Use the, I heard it, least number of significant digits. So instead of y'all yelling out a bunch of answers I can't hear in that mumbo jumbo, you got like 455. Okay, and you rounded that down to what?
400.
Odd, but okay.
460.
You're rounded to 450.
I don't say, well, if we're doing it by significant digits, wouldn't it just be like 450?
Number after the 5 is what? It's 5 and greater, so I would round to 460. All right. But if you wanted to round it to 450, I wouldn't take off for that because I told you I wouldn't mark off for your rounding. All right. But technically, because the numbers after that, because we're rounding this, right? These are my 2 significant digits. I'm keeping the 4 and the 5. Because the number after the 5 is greater, I'm going to round up. That's why I rounded to 460. But if you left it at 450, I would mark that wrong. Okay? What unit did you put on it? Because y'all did put a unit on it, right? You didn't just write 460 and stop. Centimeters what, Rebecca? Q. Very good. It sounded like you were the one who said that. That's why I was trying to give you credit for that. All right. So, now, what do we do from there? All right. So, finding the density. So, my mass is what? 34.25 divided by my 460 I just found. And so 0.074521 ought to be enough. All right, so what am I rounding it off to? Two significant digits. All right. Betsy says 2. Do we agree? You should, Because this one has how many? 4. This one has how many? So if that one had 4 and this one had 2, I only want 2 in my answer. So 0.074 has 2. However, that has a 5. So we can round up to a 5. But if you wanted to just leave it at 0.074, I would not take, whoops. All right. I haven't seen your moment again. If you want to leave it at 4, I would not take off for that. So what unit did you put on your answer? Grams over centimeters cubed. Everybody okay with that? Everybody feel good about their significant digits? Yes? No? Fabulous. How many people are here today? 15. All right, so we got an odd number. Who's not here Friday? Destiny. So Destiny's going to be in our group of 3. Now, Destiny comes regularly, so she can add more than the people who are never here. However, remember that Destiny has not been here. So I would not make Destiny necessarily the tiebreaker in an argument between people about significant digits, all right? She's learning today, so be inclusive with her with explaining the rules so she learns how to do this, okay? This is not an opportunity for Destiny to write down what the rest of y'all wrote down, so she doesn't just have to go make it up. She needs to learn how to do it. And she needs to learn how to read her significant digits so she knows how to do the lab that she missed on Friday. Possibly, it depends on how much time we have. It could be moved to tomorrow, depends on time. It might just be. Now, on the back table, there are rulers, there are the large block and the small block. I really don't think y'all will struggle with which one's large and which one's small. Now, if you do, let me know and I'll help you out with that. The triple beam balances are still on the countertop, all right? Hold on. Oh, you're just going that way. Now, before y'all get loud and start talking, the biggest thing that we need to run through very, very quickly is how to do the calculation section, because some of y'all will not pay any attention to me, and then you'll be all pissed off when I give these back, and you're like, what? I lost points for that? You didn't tell me I had to do that. So let me make sure you know, so that everybody knows and they're not all angry. Now, sometimes you have to do lab reports. Sometimes you don't. This is one you don't. This is one you just got to fill in and then turn in at the end of the lab activity, which is good because they're faster to grade than lab papers or lab reports, because lab reports some of y'all are going to hate. You know, Hyro, you're much quieter back there where I have you than you are beside Liliana for future reference. Bring your glasses tomorrow, because I'm not going to care if you can't see tomorrow, because you can't be quiet up here. I'm sure it's them, it's not you. Now, when you fill these in, nothing hard about these, okay? This is a data table. You only show your readings here. You do not show any calculations in this section. Everybody hear me? So I don't want to see any math up here. All of the math or calculations is shown in this bottom section. Now, when you show the calculations, you always show the formula. So when you show the volume calculation, you always write the formula where we did the work a moment ago. And I'm just going to make up some numbers. You just show your math, okay? Put on your units. And like I said, I'm just making up numbers. I have no idea what they are. And then when you get your answer, I have no idea what this is. I'm making it up. Some people go ahead and round to the correct significant digits. Some people write the answer and then they round to the correct significant digits. Either one is fine. When you do your density, M over V, plug in your numbers. I'm just making this up as I go, people. Okay. Now, I can very quickly look at your numbers. I can look at your calculations, and I can see if you did it right. Okay. But everything is clear. Do you see units on all of my numbers here? You have units all up here, all down here. When you answer your questions, the thing that I want to point out to you, were the densities same or different? Every year, students struggle with this concept. When you're looking at same or different, I want to say something different this year, and maybe it will help us with that. Are they very different? Meaning, if you get numbers that are really close, think of them as the same. If they're really different, then they're different, okay? So like 0.51 and 0.52 or 0.54, is that really different from 0.51? No. And people keep telling me every year those are different densities, okay? So if they're really close, they're the same, okay? They don't have to be the exact same number in both decimal places, okay? So keep that in mind. All right, everybody got it? Fabulous. The stuff is back there. You've got, let's say, 30 minutes ought to be enough time to do this, okay? Oh, and anybody who did all the even numbers, I'll leave this up here on my desk. If you want to check after the lab, you can. Since you have done the okay. Okay. English. No, they're hoping to get books because most of their paper is made in copies of books they don't have. So if they can get books, they don't need as much paper. Yeah. Okay. I just thought I'd ask. All right, everybody got a partner, got a group. All right, we're good to go.
No, 8.
You have issues here.
Not like 9 will be right on it. No, because it's right on it, it's 0. Do you have
Doesn't matter. You can make anything the length, width, and height, one of the three different sizes. Generally, and I've asked the back teacher, but it doesn't matter. Generally, most people make the longer side the length. Okay, so most people say that's the length. Most people say that's the width. And that's the height.
How does that hide?
It doesn't matter. You don't have to. You don't have to. Okay, so you don't have to. Okay, so what did you say the length was?
All right.
Yeah. It is height. Yeah.
What the length of the width and the height? I guess like you could kind of mess up, but you probably still get the same answer though, right?
So what now?
Like say like with the height and the length, I feel like you could probably get that mixed up. But even if
You
do,
could, but it's okay because
Right.
it doesn't make any difference
right?
because you don't have to make either one of them the length, the width, or the height. They can all be interchanged with each other.
That's all
The
I'm
thing
saying.
I would say to you is if you get the same measurement for something, you've made one of them the same size. Okay, they should all be different. Okay?
No, we have to count it. I know, but. What is it? It's not three, it's almost wait, no.
I've been sitting in the studio trying to get you to say.
Or late. Which I think. Oh, wait. Late? Is it late? What's late? No. Right here, we have this,
1.5.
Hey, so we just. No. We just run this.
Yes, it is centimeters. Oh, it's centimeters and then volumes.
Largest ball block in the Raleigh County.
Give me milliliter. Milliliter.
Yes. Wait, we're not
That's not. What you have in the paper? It's just what milliliter.
Talk to me.
I was right. Technically, not just.
Wait, we're only getting one side.
He said 8 points. Oh, no.
We're just looking for.
What do you have at your room?
Like this.
Hey, Rebecca.
I was in there sleep. My mother came up here. I said, like, oh. She said, why are you face red? I said, she's sleep. What? I said, I was like this. I was about to sit in the back. He told me to sit.
I guess. What is that? Right here. What is that? Is this for me?
For which one?
Oh my God. Now that got it. I dropped dead. Somebody better have a job. That make me weird. They better be even practically than that, because that is all I will come on. That is no problem. I'm not saying I'm not wrong. I'm not even wrong, so I don't sound too bad. White paper, someone else could just take it. Can you imagine?
It's 10. Oh, okay. I know.
You better have a defibrillator and I before y'all say yes. No, watch good.
I used to go out, I used to go out.
Jennifer's looking good.
I used to be really tall. I used to be out this tall shoes.
Clean up some units there in the same area.
Oh, yeah. Wait. 25.72. No, it's 57.6.
Yeah, we're different.
And then if you want to make a stack on the desk, if you tell me that you did all 40 or all 20 of the product, yeah, I got it now. I never did all. Up to you.
Feels like at the beginning, I did get it, but it rules.
You got
Oh, yeah, we put it down. I mean, you yeah.
Did she do it, like, eventually I reach together.
No. She been trying to hit me.
I don't know, yeah, but I can make it.
Let me take this one. You see right here, you got units and all this. Come put some right, you got units and all those. Centimeters. Centimeters. So you've got them on all these. All right, see how you correct them centimeters? On this side. On all those. You got them on all your answers. You got them on that calculation. On this calculation, that calculation, and that calculation. And you're good to go. If you're missing some on material, hey. I rose in the room.
I promise you. Yes, it was. He never tried.
Yeah.
Very And we're still working, should hopefully be getting close.
Alright.
Girl, you know I.
What do you think? Your roommates think.
Hey. I don't know. What, what answer? Yeah.
I didn't say no, I'm asking what you think.
Okay, what is it going to be?
Yeah, because they still, point.
Oh, this is.
For my opinion. This,
Yeah,
law.
yeah.
24, 25, and .509 is very different, right?
Not very good.
But it's different.
I would say yes.
What you plant?
I guess.
What in there? You ain't doing no work. I had more work to do than I like me.
Nobody was here yesterday.
There was no.
Today and tomorrow.
Today, tomorrow. So Monday and Tuesday, the week one. Well, there's nothing.
Rounds are in February.
Well, I actually don't.
Same block instead of issue.
Really, whatever it is. That's it, come on. I'll be back. Are you varsity? Are you doing? You're varsity, right? I don't know why you put your varsity. I'm supposed to be there.
This is my second time.
Well, you didn't play first.
I already did you score.
I'm gonna go to my desk.
I really like it.
They should move to Steve.
Because you're gonna want to make a difference, there's still an application, super significant. You could go through the process of your track and rounds.
Are you varsity?
Two significant.
Very
You're on to dividing, and you're still gonna choose significant.
Oh, that's not really your JV.
I don't know what the rest of it
All right.
Those of you still working, need to round it up and finish it up, get it up here. You're coming up on the half-hour mark.
I'm Dylan. Is that big Dylan is?
Hey, what you doing?
You got it on backwards.
I'm not.
You did it backwards.
I'm gonna find it out. So, we're standing straight. The party.
What she said?
So what happened?
So is the party.
Oh, I like.
One 26.
Oh, wait, 106.
Oh my God.
Oh, wait,
Oh, wait, 106.
Oh,
Yeah,
hell. I used to be like.
By your man.
I can guess you. She's 126. That means I'm 128.
I'm nice. I'm nice.
Oh, yeah, I lost like 2
Oh, she's white.
Whatever it is.
She was like,
Wow.
oh, one girl, she was like, I love her. Look on her. Oh, that's acting. Yeah, I don't know if you yet.
Oh, she thought she knew. Man, I was pissed. I used to have she was there for and they post me. You know, I was fire boy.
Oh, my God.
Oh, yeah.
I'm nice.
The only thing.
Then disappeared.
So you trying to redo this?
How could I do that? I was like, no. I would have told you one for it.
Y'all want to come down here and when you got your calculation, show me what's your,
Want to see my calculation?
I said,
I have to read two.
well, Trenton did it, you didn't. Tell me what it equals,
So my baby thinking about
Running out. Come on, just right down the bottom. Wrong, get them up there. Now, the only thing I would tell you to fix is see
That's
how
how we.
input units on any of those numbers. Fix it. Did y'all do it? Alright.
no.
Y'all didn't tell us. We have y'all like, y'all didn't tell us.
I told you I put the. What?
On what number?
No, I didn't.
What do you like?
Oh my God.
On the ones
Well,
where
you
you
need to
time.
see it, because I
The ones where you
No, wait, you gotta start from slow all the way. You gotta start.
Okay.
For real? Or like all the.
Miss Walker, no, Miss Bethany.
No, what?
You wanna use one of yours?
Yeah.
Make everything.
You didn't
Take the scrumpy biscuit there. Ira, what about you and Timmy back there? They can get it up here.
What is, double check?
Get it up here. What about Leandra and Destiny back there? Trenton, you and Gabriel done? Alright, y'all make sure your blocks are back on the table. The rulers are back on the table. The only thing that should still be on the counter is just the scales. Everything else should be put up. If you took a calculator over there, make sure you bring it back to your desk.
1, 2, 3.
Yes. You know, if I, like, they can do it, boy, I tell you.
I thought she was like my Can somebody short? Oh, you? Yeah. By what? Like,
Yeah, sure.
hyphenate.
Just made a donation to help pay. This rector normally has this orange thing pushed back, and I moved it forward, so make sure you know where she wants it. All right, who am I still waiting on? Who's still got a paper I need to collect? Anybody? Y'all said y'all were done.
I said we're almost done.
And half of that paper is.
I thought he said he was done and had been done. Didn't he say that?
Yeah, I'm just looking over it.
That's what I thought he said.
Yeah.
He's a liar and a pencil stealer. No.
Why is Tevin over there?
He's helping.
He's helping you. He went from I'm done to I need help. If you don't have out your orange sheets, go ahead and get those out. You're gonna need them as soon as Iro figures out if you're done or not. Oh, you wanna check the answers? Right up there beside the lamp. Down is the whole page.
Are you gonna take
Check
notes?
those. What? Let me guess, that's in the notebook too.
Everything was in the opening.
Yeah, those are the new ones, so give me that one back. These are the used ones that you may borrow.
Miss Grandma, are we gonna see notes? I mean,
Yes, we are. Just waiting on Iro, but in a minute I'm gonna buzz off and leave him. You can catch up.
I don't want to. It's really big. Not like that. And then I'm gonna go to compliment.
Go ahead.
Like this, but this one is
Bring it back, I'm here tomorrow.
yeah, it's thinner and it's like.
You know, just don't do like normal, not return anything. Will those test tubes fit in those?
To make sure. Weeks and all that stuff, which helps you back a little bit, I guess.
If you don't, let me know now. You can check the stock room. All right. I don't know what on earth is taking Hyro so long, but we're moving on. All right. Let's talk about heat and temperature. One of the things that we're going to talk about tomorrow are physical and chemical properties. All right. And the differences between the two. So today, we're going to talk about the differences between heat and temperature, because these are also two of the physical properties that we're going to work with, and we're going to look at them on our orange sheet because we're going to use them when we calculate heat in just a minute. Now, lots of you know some things about temperature and heat, and they're a lot like accuracy and precision in that we use the two words interchangeably in the English language. If you swapped out the word temperature or the word heat on an English paper, your English teacher would know what you were talking about. However, in a science class, those words are not interchangeable, okay? They do not mean the same thing. They don't use the same units, and they don't use the same equipment, all right? For example, let's start with the definition of temperature, and then we'll talk about some units, and we'll talk about how we calculate it, and then we'll compare it to heat. So first of all, what is temperature? Temperature is a measure of the average kinetic energy of the particles. I just want to make it sound right. A measure of the average kinetic energy of the particles in a sample of matter. Now, what do you suppose is the most important key phrase in that definition?
What does KE stand for?
Kinetic energy. Does anybody know what kinetic energy is for physical science? I just sort of assume people know that when they get here.
It's like, okay.
Okay, all right. KE stands for kinetic energy, in case you don't know that. It's okay if you don't. You should have learned it in middle school. And no, I don't really know who you had or how bad they were, but y'all just don't seem to be able to help yourselves with describing. All right? Which is basically moving energy. So, what do you know about all the particles I'm describing in this definition? Are they moving or are they staying still? They're moving. Okay, so all these particles are in motion. Okay? So when temperature goes up, the particles are moving what? Faster. So I measured the average kinetic energy of the particles in a sample of matter. So what's the most important key phrase in that definition? Because it's what makes temperature and heat different. Average. Okay? We're going to use a completely different math term to talk about average or heat because it's not going to be based on average. Okay? It's a completely different math word. Now, in case you weren't listening to what we just talked about, okay? I think it was Tevin who said this just a second ago. So, if we increase temperature, the particles do what? Do they move faster or do they move slower? They move faster. Okay, so whenever you heat water, for example, on the stove, the particles in the pot, when the temperature under the pot is higher, the particles move faster. The faster they move, the higher the temperature. All right, am I waiting on everybody to get caught up, or do I need to wait a little longer? Are you still riding? Okay. Got it? All right, anybody else need more time? All right, Leandra. Now, what are some units that we would use to measure temperature in? There are three that we've talked about. What are they? Fahrenheit, Celsius, and Kelvin. Whoops, I left out a letter. Fahrenheit, Celsius, and Kelvin. Now, Kelvin is the only one that does not have a degree symbol. We say degrees Fahrenheit, we say degrees Celsius, and Kelvin is just a K when we abbreviate. Now, there are formulas to convert between all of these. On your orange sheet, there is a formula for Kelvin to Celsius that's given to you. K equals C plus 273. And I want you to be able to change Celsius to Fahrenheit, and I'm going to let you write this one on your sheet. So find your second, I think it's page 3. All right, and I want you at the very bottom to write that formula. Yes. All right, you find the formula page. I think it's the third page. All right, and you can write C equals 5/9 F minus 32 at the bottom of that page. If you choose not to write it, please don't come to me and say, well, what was that formula on test day? Because it might be further back than page 3. Maybe it's page 5. Let me see the page numbers. Flip through. It's on page 3. It is page 3. All right?
We don't have the K? No, it's hard.
Yeah, the K equals C plus 273 is at the top. Okay? That's page 3. It says formulas at the top. K equals C plus 273 is at the top of the page. And then at the bottom, I want you to write the Celsius equals 5/9 F minus 32, because I'm going to ask you to use it on the test. Now, you're not going to get these same reference tables on the exam. They're going to give you new copies. So what can you tell me about that formula? Are you going to be asked to use that formula on the exam? No, you're not. Okay, this is just an extra that I want you to be able to do because you're in an honors class. Being able to use this formula is just a plug and chug algebra, quick solve the equation. Okay, but I want you to be able to do it. Everybody okay with that? Now, what's the piece of equipment that we would use to find a temperature? A thermometer. All right, and I'm only pointing this out because would we use this to find heat? Would we use this to find heat? The answer is no. Now, anybody who can't spell it, it's thermo and then meter. Okay, a thermometer is spelled thermo and then meter. Everybody got it? Now, let's say for a moment that you had to solve or use one of these formulas. All right, they're very straightforward and pretty simple. So let's say that you had, for example, 50 degrees Celsius, and you need to change that to Kelvin. All right, well, which formula has C and K in it? The first one that we wrote on the board, right? So the first equation that we wrote on the board said K equals C plus 273, right? So the number I gave you is 50 degrees Celsius, so I would plug it in where? For the Celsius, so I'd plug it in for C plus 273, and I'm looking for K. So all I'd have to do is do what? Add 273. So K equals 323, and then I'd write K on the end because that's my unit for Kelvin. Do I have to what? A degree? No. The only one that will not get a degree is the Kelvins. The Celsius and the Fahrenheit get a degree. Kelvin does not. Okay? What? That's part of the formula. Okay? That is part of the formula. So if I go back some, okay, this is the formula. Okay? So I'll either plug in the K or I'll plug in the C. If I had plugged in the K, I would wind up doing what with the 273 if I was solving for the C? I would subtract. Okay, so if I'd plugged in this letter and I was looking for this letter in math class, I would wind up subtracting the 273. But that's all I'd wind up doing in that formula. I will either be adding or I'll end up subtracting. But this is a constant. That's always in the formula. I don't do anything with it. Okay? So let's say we use this formula. Huh? Yeah.
Well, we have to what if you say Fahrenheit to Kelvin? So we have to
You'd have to do both. Yep. All right, so let's say for a moment that I give you something and I say that you have, I don't know, let's say that you go overseas. And it says that it's 35 degrees Celsius outside. And you're like, okay, am I going to wear pants? Am I going to need a jacket? Am I going to need shorts? What's the temperature? 35 degrees Celsius mean to me? How do I dress when I go outside? Some of y'all probably grew up with Celsius degrees. You're like, well, I know how to dress for that. Me? I grew up here in the United States. We only have Fahrenheit on all the signs, or if I watch the weather, it's only in Fahrenheit. I'd have to change that. I don't know how to dress for 35 degrees Celsius. Any of y'all know how to dress for 35 degrees Celsius? No? Really? Usually I get people in class who know how to dress for that. How do you dress for that? Big jacket? All right, let's see if you're right. All right, so we're going to go back, and our formula is C equals 5/9 F minus 32, right? So, whoops. So C equals 5/9 F minus 32. All right, so let's see if Hiro's right. Are we going to need a big jacket?
Tank top.
And tank top and shorts. Oh, that's what I was thinking it was, but we're going to see. All right, so 35 goes in for Celsius, because that's what they gave us. 5/9, and then F minus 32. Now, there's several different ways to solve this equation. You do whatever you know from math class, okay? Me, what do I always tell you I'm doing first? I'm getting rid of the what first? I'm getting rid of the what first? That fraction. Y'all suck at fractions, all right? I suck at fractions. I'm getting rid of fractions. All right, so the first thing I'm doing is I'm cross multiplying to get rid of that fraction. 9 times 35 is what? I have no idea, so I'm getting my calculator. I don't multiply with my head either.
315.
315 equals 5 times F minus 32. Now my fraction's gone, and the vast majority of you can work that without any difficulty. Okay? You can choose to go from dividing by 5. You can distribute the 5 through the parentheses. You choose. Okay? Whichever way you liked it better when you were in algebra class. Ms. Wall likes smaller numbers. So I tend to divide by the 5 and get rid of it because, I like smaller numbers. But if you prefer to distribute, you distribute. It's okay. So 63 equals F minus 32. Do what? I'm going to add 32. F is going to be 95 degrees outside. So 95 degrees Fahrenheit, that's going to be a tad warm in that heavy coat. Okay? So 95 degrees would be a tank top and shorts. Questions about how we use the formula? Okay? Cute bikini would look good. Maybe on Liliana, not too cute on me. Questions? Although it always amazes me when I go to the beach and people my size are wearing a bikini. I'm like, really? Have y'all looked at a beard lately? It's just not attractive. Questions? Any questions about the formulas? Feel okay about those? Okay. All right. So how is heat different than temperature? All right. How is heat different? So what is heat, first of all? Heat is a measure of the sum total of all the kinetic energy of all the particles in a sample of matter. It's a measure of all the kinetic energy, right? It's a measure of the sum total of all the kinetic energy of all the particles in a sample of matter. So what am I trying to emphasize here? What about the sample of matter? All the particles, okay? So I am trying to emphasize sum total of all right? Not an average this time. With temperature, we're talking about an average. Some of y'all have jobs, right? Do y'all want to be paid on your average hours or your total hours? Total hours, because it adds everything up together, right? You get paid more if you get paid on total hours than you get paid on average hours. So heat is that way. It's a sum. For example, suppose that we have a cup of coffee. It's the only thing I can draw. Don't get excited, because now I'm going to mutilate the next one. I told you it was going to be bad. All right, so I got a lovely bathtub here. Which one has more heat? Here, let me fix that so we can actually read that. Which one of those has more heat? No.
That's what it is?
It's more water.
What? And that is the reason. Salma gave us the right answer with the right reason. All right? It has more water. It doesn't matter that the bathtub water is cooler. The reason is there's more what? There's more water. Okay? So, catch up with me, and I'm going to write down a question on the next board, and we're going to talk about why that is the way it works. All right, we caught up?
Yeah.
Okay, but okay.
She's doing it.
Everybody there? Yes? All right. So, which has more heat? Okay. A pool in August, cup of coffee, a frozen lake, a warm soda. Which one has more heat?
See. See.
Oh, no, it is.
All right, I got C.
What is that first one? Awesome.
A pool,
Oh,
or swimming pool.
I was gonna say, I know.
Yeah.
See.
In August, the warmest part of the summer.
See.
I agree. The answer is C.
I gave it.
All right.
I gave it.
All right. The answer is C. Even though the lake is frozen. All right. The reason is it's huge. It has more particles. The thing you have to keep straight about heat is heat equals size. All right. Heat is about size. The bigger the size, the more heat it has. Have you ever noticed fat people are hot? Fat people are hot because they got more particles, okay? Very rarely do I get cold. I don't get cold very often because I got all these particles, okay? Skinny people get cold. Now, temperature, and that's just a general statement. It doesn't apply to everybody. All right? Temperature is about motion. All right? The faster the particles move, the higher their temperature is. All right? But heat is about size. So the bigger the sample size, the more heat it's going to have. Okay? So even though that lake is frozen, it still has more heat than that pool in the middle of August that we all jumped into that were like, man, this was like bath water. It's hot. Okay? Everybody there? All right. Can we talk some units and how we measure it? Everybody caught up? All right. So how do we measure, say, equipment? All right. How do we measure heat? Huh? Yeah. All right. How do we measure heat? We're going to do this. Given that we have an hour and 5 minutes, I suspect at the end of the semester we will not be behind. All right, and we will be able to do this lab. We were behind first semester because classes were so big, and y'all's is a smaller group. And we have an hour and 5 minutes, so we will probably get ahead by the end of the semester. So we're going to be able to do this lab. All right, we're going to use a calorimeter, or some people say calorie meter. It is pronounced calorimeter. It's a fancy piece of equipment to measure change in heat. However, we're a poor school, so we're going to use a styrofoam cup. All right, it'll work great. I know. The units that we use, all right, we're going to use the joule. All right, Joule is pronounced joule, not jowl, like somebody's jaws. All right. The calorie is one you're probably more familiar with. All right. The calorie, though, is the English unit. All right. So we're not actually going to calculate with the calorie, but I put that up there because you guys are probably more familiar with it, probably talk about it in foods. I know you see it on the sides of cans and things like that. So I put that there so you're familiar with it. Now, the last thing I'm going to write up here that we're going to learn to use tomorrow, it's where we'll begin our lesson at. All right? The formula that we're going to learn for tomorrow is Q equals M CP delta T. So when I say to y'all tomorrow, where did I leave off and what do I need to pick up with? Y'all tell me there. Now, your homework tonight, I did not give y'all the even problems to do. Your homework is to practice the evens so that you can study for your what tomorrow? Quiz. Yes. Huh? The quiz. We will do the quiz right after the open tomorrow. Yes. Oh, make sure I get your lab sheet. Don't be like Betsy Bay over here and she's still got it on her desk. I can't grade it if you don't give it to me. So did I get everybody's lab paper? All right. If you need to make up anything, if you're like Destiny, you missed a lab or a quiz last week, I'll be here Tuesday, Wednesday, and Thursday this week. So come get it made up. You've got